ACID, which stands for atomicity, consistency, isolation, and durability, are four critical properties of relational database systems. I think any engineer working with relational databases such as Postgres, MySQL, SQL Server, Oracle, and even NoSQL databases or graph databases must really understand these four building blocks and fundamentals and first principles that build database systems. In this course, we'll go through these four properties in details, and I'll explain why each of these properties is critical to build and use relational databases successfully. Let's get started. So part of the work that we're going to discuss in this section is what is a transaction. Before we even start talking about these four properties, we really need to understand what is a database transaction at its core. And once we understand this, then we're going to jump into the first property, atomicity. What is it exactly? Why is it the most important thing to guarantee consistency? Speaking of consistency, we really need to talk about the transaction isolation. As I start multiple transactions concurrently, all of these are accessing my data, all of these transactions at the same time changing my data. What does it mean to for these transactions to be isolated from each other? What can they see? What should not they see? All these results into the consistency fourth parameter. I flipped the order here because I really believe talking about atomicity and isolation before consistency is actually critical to understand consistency. Because now if you have a transaction and this transaction changes something that I just wrote, then you're going to get a result that is unexpected. That affects your consistency. You get a data that you didn't expect it. It's bizarre, right? And finally, the most important one of the most actually, and one of the properties that a lot of NoSQL databases play with, durability. Some databases sacrifice durability for performance, and nothing wrong with that. It's just understanding the concept of durability, that when I actually commit a transaction, when I actually say save, this should really be persisted in a non-volatile place so that I can go back and read this data, even if my database is crashed, even if I lost power, I can still get access to my data. We're going to talk about all of these in detail. If you are interested in this thing, stay tuned and see you in the next lecture. Oh, forgot to mention one thing. By the end of this section, I added a little bit of a small quiz that I think you guys were going to enjoy. And obviously the answers are in the quiz. And even if you pick any wrong answer, I give you detailed explanation why that answer is not the actual correct answer, right? And we have all sorts of great discussions in this course as well.